In this video, we'll discuss coordinate geometry. Now, when we think about the coordinate plane, that is constructed with two perpendicular number lines, and their intersection occurs at the origin, which we label as 0, 0. This creates four quadrants in the coordinate plane, starting in the top right and then going counterclockwise. This can be helpful because maybe you have a problem that lists that the issue is in the third quadrant. So you know that's the bottom left quadrant, and both the x and y value have to be negative there. Also, we know that the ordered pairs that are on the coordinate plane are in relationship to the origin. How do we get to that specific location? So when we see an ordered pair labeled as 3, 2, we know we started at the origin, we went right 3 units and up 2 units to get to that location. You remember, points are just exact locations on the coordinate plane. They are not objects. There's no length or width to them. It's just telling us where we are. So if we want to calculate the distance between 2 points or the length of a segment, we will use what's called the distance formula. And we have to have two ordered pairs to do this. And what we're going to do is we're going to take the square root of the differences of the x's squared plus the differences of the y squared. It does not matter what you call the first or second ordered pair. It's just a matter of being consistent, so that whatever you call the second x is paired with the second y. And keeping that consistent is what's important. Now say we have here a segment that's on our coordinate plane, and we want to know, well, what's the length of AB, or the distance from A to B, or the distance from B to A. It does not matter because measurements are always positive. First thing we need are the ordered pairs. And remember, that's in relationship to the origin. So we'd say that A is 1 unit to the right, 4 units up, and B is negative 3 units, and then up 2 units. We can then substitute the values into our distance formula, and I did use B as my second ordered pair, and that's fine. Just pay attention to your negatives as you go along doing this. Negative 3 minus 1, 2 minus 4. And then as you simplify, make sure you're recognizing that you're keeping your parentheses, because if I put this in a calculator, negative 4 squared is different than saying negative parentheses 4 squared. So we know that negative 4 times negative 4 gives us positive 16. So it's important to have those parentheses there to get our proper numbers. That'll simplify to the square root of 20, and we want to make sure we simplify our radicals, and that'll be 2 the square root of 5. Now we can also calculate the midpoint between 2 points. That's the equidistant location between two given points on the coordinate plane. And we can calculate that by averaging the x's of our two ordered pairs and then averaging the y's of our two ordered pairs to get that very specific ordered pair in the middle, called the midpoint. Again, doesn't matter what's the first or second ordered pair as we're doing this. So if we started with that segment again, we knew our points. We would average the x's, and then we'd average the y's, and this would give us negative 2 over 2, comma 6 over 2. If I simplify, that's negative 1, 3. And if I plot that on my number line, or on my coordinate plane here, I would see that it is exactly in the dead center between A and B, and I'd create two congruent segments from that midpoint to each endpoint. Now, if we move from a segment to an entire line, we could look at the slope, which is recognizing the tilt that occurs on that line between any 2 points that exist on that line. It doesn't matter what two, they will always have this same slope between them. And what we're going to use is our formula that the slope, which we label as m, equals y2 minus y1 over x2 minus x1. In other words, the differences of our y's over the differences of our x's. That's why we say that slope is rise from our y values over run from our x values. So say instead of a segment, we made this a line, and we're looking at the slope of line AB. We still have those same two ordered pairs, but now we can determine their slope, or their tilt that's on the coordinate plane. We subtract the y's over subtracting the x's. 2 minus 4, negative 3 minus 1. And pay attention to your negatives. It's always important, because you end up with negative 2 over negative 4, which simplifies to positive 1/2. So that slope is positive 1/2. Doesn't matter where I am on the line, it'll always have that same slope. But we can see that by using the very broad lines that are drawn on the grid, and see that our rise is 1 and our run is 2 every single time. Rise, run, rise, run. Now, if we need to calculate the equation of a line, we need to recognize that that equation is a relationship between two variables, often x and y when we're graphing, but it could be between two other variables depending on the problem we're working. We often will put these in two different forms. One's called the standard form, the other's called the slope-intercept form, and it often depends on what it is we're looking for in the problem. Just remember that when you are in slope-intercept form, our m value is our slope, our b value is the y-intercept. In other words, where does it cross the y-axis? So when we want to determine the equation of a line, we first need to find two ordered pairs on that line. We then want to determine their slope. Then we're going to substitute one of the ordered pairs, either of those two ordered pairs, and the slope into this formula, and then simplify it to meet one of these two forms based on what I'm being asked for. Maybe I'm being asked for the standard or the slope-intercept. Just match whichever one. But the little subscript tells us that's an ordered pair value. Subscript here, ordered pair value, and the m is the slope. So we're keeping this y and this x. That'll be part of the equation. That's important. Then we just rewrite it based on slope-intercept or standard form. So let's look at an example. We're going to go back to our points A and B. So first thing we need is the two ordered pairs, which we already have. We just calculated the slope a minute ago, which we said was positive 1/2. Now we're going to turn this into the actual equation of the line through points A and B. So we can choose either ordered pair. It does not matter which one. I'm going to choose point A and use that ordered pair just because it's the first one listed. So when I'm going to plug in here is I've got 4 in for my y value, 1 in for my x value, and 1/2 in for my slope. And now I simplify. So I distribute the 1/2 to both terms. Now I want this in slope-intercept form, so the slope-intercept form is y equals mx plus b. So I need to get rid of this -4 on the left-hand side. So I add 4 to both sides, and then -1/2 plus 4 is 3.5, or I could say that y equals 1/2 x plus 7/2. And we knew the slope, and if you look here, where is it crossing the y-axis? It's crossing the y-axis at 3.5. Now the last thing we'll talk about is the idea of whether two lines are parallel or perpendicular. If we have the two lines and they're in slope-intercept form, we can very easily tell. In slope-intercept form, we can check the slopes. They're parallel if and only if they have the same slope. And they're perpendicular if and only if they are the opposite reciprocal. That's two pieces. Opposite means one's positive and one's negative. Reciprocal means that it's that fraction flipped. So 2/3 versus -3/2. Let's look at some examples to help us here in just a minute. And remember, putting them in slope-intercept form is always helpful because we can look directly at the slopes. So here we have y equals 3x plus 7, y equals 3x plus 12. They're in slope-intercept form, so let's look at the slopes. Positive 3 over 1, positive 3 over 1. They're the same, so they have to be parallel. Here we have -4/5 x plus 8, and here we have positive 5/4 x plus 22. -4/5 to 5/4, they're opposite. 4/5 and 5/4 is reciprocal. So they are opposite reciprocal slopes, which means they're perpendicular. Let's look at one last example. Here we have -3/5 x plus 1, and the other line is y equals -5/3 x plus 1. They are both negative, but one's the reciprocal of the other. They're only reciprocals. There's no opposite. Since they're only reciprocals, there's no relationship. They will intersect somewhere, but it will not be a perpendicular intersection.